Amazing people. Now we're being given a function here, which is f of x equals 3 to the x. And what we want to do is we want to sketch kind of alternatives of this, where slight changes are made. Now, the changes we have to make here are y equals negative 3 to the x, y equals 3 to the negative x, and y equals negative 3 to the negative x. So what we're going to do is we're going to pay attention to what happens here and try and understand as we graph each of these. First up, what we're going to do is look at this first one here, which is y equals negative 3 to the x. Now, the changes which are going to happen with this graph are relating to the values. It's going to create a reflection over the x-axis. So anything which is positive is now going to change and become a negative value underneath the x-axis. So largely, it's still going to pass through, but instead of passing through 1 of the y-intercept, it's now passing through negative 1. So it's going to pass through there. And then as it continues on, it's going to meet its point. So if I graph this now, I'm going to pass through there and start to increase exponentially. We will have at x equals 1, a y-intercept of negative 3. And we can plot that point on here, which is going to be 1, negative 3 as well. So you can see the changes which have taken place with this graph here. Now the y-intercept is going to remain the y-intercept. Now the asymptote will remain the same, and that will still be the x-axis in this case. Okay, and make sure to indicate it with a broken line. Now the next one we're going to focus on is where we are applying a negative to the indices here. Now in this case here, when we're applying the negative, what that's doing is it's kind of flipping it a little bit. So what it's going to do is make the numbers which were really large now be really small fractional numbers. And the numbers that were once fractional now become really large. Effectively, it's creating a reciprocal version of this graph. One thing though, if x equals 0, where we have the y-intercept, it's still going to be 1, so it will pass through that place there. When x equals 0 and we have the y-intercept, y is still going to be 1, so it's still going to pass through there and have that same y-intercept. But other than that, in this case, what's going to happen is it's going to mirror using the y-axis as that mirror. So what happens is it's going to instead have a high point as it's on the negative side of the x-axis, and it's going to have quite a low flat one on the positive side of the x-axis. Again, the asymptote will remain unchanged, and that's going to be the x-axis. And if we just plot our other point here, we're going to have minus 1, 3 for that extra point there. And remember to label the graphs appropriately as well. For this last graph, we've got y equals negative 3 to the power of negative x. Now this is going to be a twofold shift here. First of all, it's going to create a mirror image, but it's also been going to of the y-axis and then a mirror image of that over the x-axis. Or alternatively, it can create a mirror image over the x-axis and a mirror image over the y-axis. So what's going to happen here is the y-intercept is going to shift to minus 1, but now as well, what's going to happen is as it shifts, rather than have the larger part on the positive side axis, this now becomes the flat part of it there, and the asymptote remains the x-axis, but then it's going to shift up quickly like this. So you can see how it's a mirror type image as it's flipped twice. So we'll have that as minus 3, that as minus 1, and let's just indicate that. So this point here will be minus 1, minus 3. So you can see the double inversion that's occurring here when we've got the two negatives being applied.